Hey, welcome to my living room. Today we're going to be talking about review lab number 3. It's called Don't Hit Your Friend in the Eye, which I guess will not be as much of a problem because you're doing this as a video lab, unless you somehow manage to throw your phone in someone's eye. But if you're planning on that, I'd recommend goggles. Good safety feature. Before we get to some data collection, I just want to show you our setup. So we have a good old-fashioned string. On one end is tied this rubber stopper. It's your standard 2-hole number 6 stopper, if you're a stopper fan. String goes through this piece of glass tubing, and then on the other end of the string, we have a hook where we can hang a different number of washers. So the idea is, you'll see me do several trials where I am using different numbers of washers, and I'm kind of swinging this thing around like this. So I'm going to give you certain information on the screen that you're going to need in order to do your calculations. You are going to have to use the video to measure the period of rotation. Best way to do that is by using a stopwatch or a timer on your phone and recording the amount of time it takes to complete 10 revolutions and then divide by 10. So I'm going to do one video clip for each trial. Each trial is going to have a different number of washers. So as you're watching, make sure you write down all the information that's on the screen and then use some kind of timer to figure out the period of rotation. You're going to see at least 10 rotations in each video. I'll try to let them run a little bit longer so you can get some good data. And you will maybe not figure out this is a pretty inaccurate lab. We're making lots of assumptions. So one of those assumptions is that when the stopper is going around in a circle, we are going to pretend like it is completely flat. So the tension force is a centripetal force. In reality, it's down at some kind of angle like this. You don't have to worry about that. You can just assume that it's completely flat. Also, we're assuming the string is massless because we don't want to have to worry about that at all. So the basic situation is if we keep the stopper spinning at a constant radius, the tension force in this string is going to be equal to the tension force in this string because it's the same string. The glass tubing just changes the direction. We'll pretend like it doesn't add any friction either. And the force down here, which is going to be a weight, gravitational force, is going to be equal to the tension force, which is a centripetal force on this stopper. That should help you set up the calculations. So if you haven't done the derivation yet, you can pause this video, do the derivation, and then the rest of the video is going to have some data for you to collect.